Till now, we've learned how the leading strand is being synthesized. This video, I'll be dedicating it to the synthesis of the lagging strand. Now, the synthesis of the leading strand is continuous and there's no problem about it because the orientation of the DNA is the 3' to 5' orientation, and that's how the DNA polymerase can act. But there is a problem with the lagging strand, and that is because the DNA orientation is different. Now let's look at this structure of the DNA. Now this is the 3' end has been shown with the red color and the 5' end has been shown with the blue color. Now this is if the replication bubble is moving from the left to the right, we find out that the leading strand will be synthesized on the top strand. So that is one primer. We also said that the helicase and the primase joins together to lay multiple primers for the lagging strand. So in the opposite strand, as the helicase moves forward, the primase puts multiple primers at random places around 200 to 300 base pairs in length all across the opposite strand. So let's just zoom up this area of interest and see what's happening. The top DNA is in the 3', 5' orientation. The primer which binds, this will be the 5' end, this will be the 3' end. This is going to give us the 3-OH group, and the synthesis of the leading strand is continuous. There was no problem about it. But if you look at the lagging strand, this is the 5' end and this is the 3' end. Now the three this is the 5' end and this is the 3' end. We need the OH from the 3' side for the synthesis of the DNA. So now you understand that the DNA polymerase will not be able to synthesize the DNA like this. It will be able to synthesize the DNA the opposite way, but not in this direction. But we made a statement that the replication bubble goes bidirectionally and both the strands are synthesized simultaneously. So there has to be some different mechanism to enable this part of the DNA to be synthesized simultaneously as the leading strand is being synthesized. The problem is the orientation of the primer. To overcome this, what the body does is it causes a small looping of a segment of the DNA. The looping starts here. This is partially completed. It's almost a 180 degrees loop. If you look at the DNA right now, this is the orientation. This is the 3' end. This is the 5' end. After the loop, you'll find that the 5' end is here and the 3' end is here. Let's get back again. This is the orientation. This is the 5' end. This is the 3' end. This undergoes a 180 degrees turn. When it undergoes a 180 degrees turn, this becomes a 5' end, this becomes a 3' end. Let's extend it further. For a full complete loop, you'll find that this primer is the 5' end, this is the 3' end. This is in the same orientation as the strand on top. Now the DNA polymerase will see that both these fragments are in the proper orientation and start synthesizing both the strands simultaneously. If we actually zoom out and straighten up this loop and see what's happening, we'll realize that this leading strand is being synthesized continuously from the back to the front, whereas the opposite strand, the lagging strand, is being synthesized from the front towards the back. That's because the DNA was actually looped and the loop is being synthesized from the front to the back. This synthesis will keep continuing until the new DNA formed all the way up to the previous primer. Once we form this segment of DNA all the way to the previous primer, then a frame shift occurs. The next loop of DNA gets flipped by 180 degrees. Again, the orientation is the same as the orientation in which the leading strand is being synthesized, and this fragment starts getting synthesized all the way till the previous primer. This way, you find that the leading strand is being synthesized continuously, whereas a lagging strand is being synthesized discontinuously. For every loop, we need to have a primer, and that's why the helicase binds with the primase binds with the helicase, and as we are going in the direction of the replication bubble, It synthesizes one primer for the leading strand and multiple primers for the lagging strand. It also explains this diagram where we say that the leading strand is being produced continuously, whereas the lagging strand is being produced discontinuously from the front to the back. This is going from the back to the front in the direction of the replication bubble. The lagging strand is being produced from the front to the back. Thank you.